Okay, good evening, all of you. So, this is the next class on conic section. So, in the previous class, we have discussed about the concept of conic and conic sections. Why the name is conic section. And also, we have discussed the first type of conic section, that is the parabola, and different types of parabola, some definitions related to parabola, and some real life applications of parabola. Now, today we'll discuss about ellipse and hyperbola. So first look into the definition of the ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two fixed points in the plane is a constant. The two fixed points are called the foci of the ellipse. So you know that I told you the definition of the conic. So in that case, SP, the ratio SP by PM is equal to a constant, and the constant is known as the eccentricity. So S is the fixed point, this is called the focus. P is the movable point anywhere in the plane, and this is the directrix. So you have SP, and this is the perpendicular distance PM. SP by PM equal to E, eccentricity, and the locus of P is called the ellipse actually, and E must be less than 1 for ellipse, okay, and E equal to 1 for parabola and more than 1 for hyperbola. That's the criteria. Now, an ellipse is a set of all points in a plane. This is the new definition. Another definition, the sum of whose distances from two fixed points in the plane is a constant. So this is the point. This is the fixed points. Suppose S1, S2, and this is the point P. So these distances, sum of the distances are constant. Okay, S2. This is your S2. S1P plus S2P equal to constant. The two fixed points are called the foci of the ellipse. So this is another definition of the ellipse. Now you look at that. These are the focus 1, focus 2, and the line connecting focus 1 and focus 2 is called the major axis. And this remains constant according to the definition of the ellipse. Then the path of this point is called the elliptic path, right? Because you can see the planets revolve in an orbit that is elliptical, revolving the sun, and sun is at its one of its focus. Sun will be one of the focus, this or this. In this case, there may be some definitions of aphelion and perihelion, you know that. So this is the major axis, is the red one, the connecting the focus is called the major axis, and the green one is called the minor axis. Okay, the line through the foci is called the focal or major axis. Now for ellipse E less than 1, from the definition, SP equal to EPM, or if you square, then SP squared equal to E squared PM squared. From this you will get this type of equation of the ellipse. So equation of the ellipse is given by x squared by a squared plus y squared by b squared equal to 1. This is the equation of the ellipse. The figure of the ellipse is symmetrical about both the axes. These are some important things to know. You see that this is, if you consider this one as x-axis and this one as y-axis, then ellipse is symmetrical about x and y-axis, both the axes. This is symmetric diagram. So that's what was explained here. The figure of an ellipse is symmetrical about both the axes. An ellipse has a second focus and second directrix. Obviously, if you have a second focus, focus 1, focus 2, so this side you might have a directrix, and this side also you have a directrix. So you have two directrices and two foci. So the ellipse is bounded curve lying in the rectangle formed by the straight lines x equal to plus minus a and y equal to plus minus b. It is also interesting fact. So this point is actually a comma 0, right? And this point is in, these are the vertices actually, minus a comma 0 on the negative x direction. And this is your 0 comma b, ends of the minor axis, and this is your 0 comma minus b, right? So what is the length of the major axis? 2a. What is the length of the minor axis? 2b. Clear? So these are the ends of the major axis, and these are called vertices of the ellipse. And this is the center. Center is 0, 0, right? Center is origin. Origin is the center. So it is bounded by the rectangle. It is inside the rectangle. If you draw the rectangle, okay, if you draw the rectangle, it will, the ellipse is contained in the rectangle actually. Rectangle of sides 2a and 2b, length 2a and breadth 2b. The sum of the focal distances of any point on an ellipse is constant. That already we define, and is equal to the length of the major axis. This is another property. The sum of the focal distances of any point on an ellipse is constant and is equal to the length of the major axis. So what is the length of the major axis? 2a. Length of the major axis is 2a units. So let's have some information about the ellipse. So if you draw the ellipse, this is the ellipse x square by a square plus 1. This is the first form where a square is more than b square. That is a square is along the x axis, x direction. Okay. So this is the ellipse, right? It's not a good diagram. Let me draw a good diagram. Yeah. This is the ellipse, and this is the, suppose this is the major axis, this is the center at 0, 0, right? And you have the major axis vertices a comma 0, 0 comma minus minus a comma 0. This is negative direction. Okay. And this is minor axis 0 comma b along y direction, and 0 comma minus b. So length of the major axis is 2a units. Length of the minor axis is 2b units. Eccentricity of the ellipse is given by E equal to root over a square 1 minus b square by a square. E equal to 1 minus b square by a square. This is the eccentricity E. You can calculate that. Eccentricity is given by this if a square is more than b square, right? And foci. So there foci is plus minus a comma 0. This is positive, this is negative. So let me show you here. Yeah, this is the focus 1. S, this is AE 0. Okay. Focus, coordinate of focus is given by AE 0. And the another focus is given by minus AE comma 0. Where E is the eccentricity. E is given by root over 1 minus b squared by a squared, provided that a squared is more than b squared, right? So this is the foci, and you have the directrices also. This side you can draw the directrices. Yeah, and distance between the foci is 2ae. You see S prime is 2ae, twice ae, right? The distance between the foci. So you see the distances is given by 2ae, and equation of the directrices is x equal to plus minus a by e. So this side you have, this coordinate is a by e comma 0, and this side you have minus a by e comma 0. So distance between the directrices is given by 2a by b, twice a by e. That is the directrices. Yeah, equation of the directrices is x equal to plus minus a by e, and length of the lattice rectum is 2b square by a. So you have the lattice rectum perpendicular to the major axis and through the focus. This is the lattice rectum L, L dashed, L1, L1 dashed, and there are two letters rectum, L2, L2 dashed, right? So this length is 2b squared, twice b squared by a. You look at that, this length is twice b squared by a units. So this is symmetric about the x-axis. So this is base square by a. So the coordinate is given by AE. The extremities of the lattice rectum is given by AE b squared by a. And this one, L1 dash, is given by AE minus b squared by a. Right? And this side also you can calculate minus AE comma b squared by a minus AE comma minus b squared by a. I'm writing the third quadrant. In the third quadrant, minus, minus, right? And this one is minus AE b squared by a. Okay? So these are the extremities of the lattice rectum. This is all the information in one ellipse. And major axis is along the x direction, x axis, and minor axis is along y axis. So this all about your ellipse. And the distance between the directrices is 2a by a units. Already we discussed. Distance between the focus is 2ae. These are all important informations. Now, your form of the ellipse can be, you can take in, suppose the ellipse is given by, if b squared is greater than more than a squared, right? What will happen? Then your ellipse will be like this. You can take the ellipse like this. This is your y direction. So your major axis is actually twice b units, b, right? And minor axis is twice a. So in this case, b square is more than a square. So x squared by a squared plus y squared by b squared equal to 1, provided that b square is more than a square. So all the informations will change. The foci will be on the y-axis, right? So all the informations will change. So this is another form. And you have a general form if the center is not at the 0, 0 origin. So if your center is shifted to some other point, suppose this is your center origin, but your center shifted to alpha comma beta, some other point, then accordingly you have to change everything. So this is the equation of the ellipse whose center is at alpha beta and whose axes are parallel to the coordinate axis. So this is the ellipse where a and b are the, obviously a square is more than b square, so you can take the parallel axis, parallel to x axis is the major axis, right? So another general equation you can take, suppose alpha beta be the focus and Lx plus My plus Nz equal to 0 be the directrix, and E less than 1 be the eccentricity of the ellipse, and P be any point of the ellipse, then you can apply this formula. Obviously there is a E square, SP square equal to E square PM square, then you can get, this is the general equation of the ellipse, right? You can write this form. And already discussed 3.3 here, and you can see a clear picture of ellipse. So d1 plus d2 equal to constant always, and the constant is actually the major axis. So these are the vertex, you see the red dots, and the focus, green dot, center, major axis, minor axis, that we have discussed all this. Now this is the chart form. For your better understanding, you can have a look on that. This is the form of the ellipse. Okay, there are two charts. One is along x-axis, major axis is along the x-axis, and major axis is along the y-axis. You can take a help of that. So all the informations are there. Now standard forms, if the center is not at 0, 0 but it shifted to alpha beta or hk. So in this case you see the focus will be, if it is at hk, then the focus will be h plus c comma k, and the vertex will be h plus a comma k, and here the focus will be h minus c comma k. This is the first diagram, and also you can check the focus is given here and center is hk, and the parallel a major axis is parallel to the y-axis. If this is the form, b square is more than a square, then you can calculate the foci and the vertices. Again the chart in much simpler form. So next point is, what is the auxiliary circle? What is the auxiliary circle of the ellipse? The circle described on the major axis of an ellipse as a diameter is called the auxiliary circle of the ellipse. Let the equation of the ellipse be x square by a square plus y square by b square equal to 1, provided that a square is more than b square, that is major axis is along the x-axis. So equation of the circle on the major axis as diameter is x square plus y square equal to a square. This is called the auxiliary circle of the ellipse. Let's have a diagram. Yeah, you see this is your major axis. A dash is the major axis. So if you take major axis as the diameter and if you draw a circle, that circle is called the auxiliary circle of the ellipse. This pink circle is called the auxiliary circle of the ellipse, right? And few observations. P point on the ellipse and Q draw P and perpendicular to the major axis, the NP is produced to meet the auxiliary circle at Q are called the corresponding points. So you see, if you draw P is a point on the ellipse, if you draw perpendicular, that foot of the perpendicular is N, that is on the major axis, and it will cut the auxiliary circle at Q. So P comma Q are called the corresponding points. P comma Q are called the corresponding points. And you can see that angle is subtended by CQ. This angle is called the eccentric angle. This angle theta is called the eccentric angle of the ellipse. And also you can observe Pn, the ratio Pn by Qn is equal to B by A, is equal to the minor axis by semi-minor axis by semi-major axis. This is the ratio. The ratio is given by the ordinates of the corresponding points are in the constant ratio. Okay, these are the important observations about the auxiliary circle. So auxiliary circle is nothing but it is drawn on the major axis as a diameter. And also for a parametric form of an ellipse, we have seen that T is the for parabola, the parametric form is 80 square comma 280. So in this case, parametric form of an ellipse is given by a cos theta comma b sin theta always lies on the ellipse. For any value of theta, the point a cos theta comma b sin theta always lies on the ellipse. This, so theta is the parameter, actually parametric form of the ellipse. Next, I will define hyperbola. So hyperbola is nothing. The hyperbola is the locus of a point which moves such that its distance from a fixed point called focus is always e times its distance from a fixed line is called the directrix, line called directrix. So that is the definition 1 for the hyperbola. And definition 2, it is the locus of a point which moves such that the differences of its distance from two fixed points remains constant. That is ps prime minus ps is constant. That is the hyperbola. Definition of hyperbola. There are two definitions. You can take a help of that. And you can have a look on the hyperbola. This is the hyperbola from the definition. There are two branches actually. And this is called the transverse axis. And this is the y-axis. Along y-axis, it is called the conjugate axis. Focus, F1, F2, vertex, center. Okay. And this is always constant, the distances. And the equation, you just have the result of the ellipse. You just substitute b square, replace b square by minus b square in the ellipse. You will get hyperbola. All the results will be for hyperbola. Nothing you have to do for it. You have to replace b square by minus b square in the results of the ellipse. You will get all the results for hyperbola. So foci are same, plus minus ae comma 0, and eccentricity is given by b square is equal to a square e square minus 1, because b square is replaced by minus b square. And equation of the directrix is x equal to plus minus a by e. And we define here equilateral hyperbola or rectangular hyperbola. A hyperbola whose length of the transverse axis is equal to that of its conjugate axis is called the equilateral hyperbola. Or rectangular hyperbola, equilateral hyperbola or rectangular hyperbola. So the standard equation of the equilateral hyperbola is, that is in this case, a square is equal to b square. So x square minus y square is equal to a square, and you can easily check that the eccentricity of the equilateral hyperbola is √2. Okay, so that is your hyperbola if transverse axis is equal to the conjugate axis. So this is the picture of a rectangular hyperbola. X square minus y square is equal to a square. It is rectangular or equilateral. And this is the xy equal to c square is another form, because you see you have the equation x square minus a square equal to y square equal to a square. So you can write, okay, you can write it as x minus y into x plus y as a square, right? So x minus y, as you can substitute x, and x plus y or y, so it is in this form. Xy equal to c square is another form of the rectangular hyperbola, right? And conjugate hyperbola. Let the hyperbola have a dash as transverse axis and b dashed as conjugate axis. The hyperbola which has b dashed as transverse axis and a dashed as conjugate axis is called its conjugate. That means you just the hyperbola, you are considering a hyperbola which has b dashed as transverse axis. That means the axes are changed. Transverse will be changed into conjugate. Conjugate will be changed into transverse. Then these two hyperbolas are called conjugate hyperbola. So the equation of the conjugate hyperbola is thus given by these equations. Okay, these are the conjugate hyperbola. That means you have a transverse axis for one hyperbola, and that will be conjugate axis for another hyperbola. So E1, E2 are the eccentricities of hyperbola and its conjugate respectively. Then you have a relation 1 by E1 square plus 1 by E2 square equal to, you can write them as 1. That can be equal to 1. You can prove that for a conjugate hyperbola, 1 by E1 square plus 1 by E2 square equal to 1. And E1, E2 are high eccentricities of the hyperbola. So this is the conjugate hyperbola diagram, for very hazy, but you can check that this is the conjugate hyperbola. You can draw the square on taking the focus. These are the diagram of a conjugate hyperbola. And you can define an auxiliary circle here also by considering transverse axis as the diameter. You can consider the transverse axis of the diameter. You can take the auxiliary circle. Equation of the auxiliary circle is again given by x square plus y square equal to a square. Okay, so this is the auxiliary circle, and in this case also you can take the parametric form a sec theta plus b, comma b tan theta. So I have explained. And this is the elliptic path. This is the real life applications, elliptic path of the planets, and some architecture using some elliptic and hyperbolic concept also. So that's all for today. I hope this lecture is helpful to you. So please follow my lecture videos on YouTube channel. Thank you all of you.